Hello statistics students, this is Mr. Cazzato and today's lesson is about z-scores. So during the lesson we learned that the z-score is equal to the value minus the mean over the standard deviation. If we were to write that in symbols, it's x minus mu over sigma. So for part A of this problem, we want to know the z-score if the value is 1.95 and we have a mean, I'm highlighting this in blue, is 1.29, and we have a standard deviation that I'm highlighting in green, 0.35. So to do part A, the z-score is 1.95 minus 1.29 divided by 0.35. When you do that on your calculator and you round the two decimals, you get 1.89, and you do want to round correctly here, 1.89. For part B, we're going to use the same calculation. Z is equal to the value, in this case it's 0.88, that's this number right there that I put the arrow next to, minus the mean, 1.29, and we're going to divide by 0.35. When you do that on your calculator, you get negative 1.17. So the answer here is negative 0.117 when you round the two decimal places. Now it's important when you use your calculator, if you're typing this in, you want to put parentheses around the numerator. Okay. And then the other thing we want to talk about is how do we interpret the 1.89. The interpretation of the 1.89 in this particular case is the measurement of 1.95 centimeters is 1.89 standard deviations above the mean. The interpretation of the negative 1.17 is the measurement of 0.88 centimeters is 1.17 standard deviations below the mean. Okay, in problem number 2, you can take a minute to read that. So we want to calculate the z-score. I'm going to highlight the mean. So we have a mean of 69.7 inches, and we have a standard deviation of 2.64 inches. Okay. And that's for the men. For the women, the mean is 64.1, and the standard deviation is 2.53. So for part A, if a person is 75 inches tall, we want to calculate the z-score. So the z is going to be 75 minus the mean for the men, 69.7, and we're going to divide by the standard deviation, 2.64. When you do that on your calculator, you get 2.01 when you round the two decimal places. So 2.01. For the female that is 5 foot 11 inches or 71 inches, we're going to use the numbers that I highlighted in blue. So the z-score is going to be 71 minus the 64.1, and we're going to divide by the 2.53. Again, if you're using your calculator, you want to make sure you put parentheses around the numerator. When you do this on your calculator, you're going to get 2.73. So again, the interpretation of the 2.73 here is this woman that is 5 foot 11 inches is 2.73 standard deviations above the mean. And the interpretation for the 2.01 for the man is his height is 2.01 standard deviations above the mean. So then to answer the question here, who is relatively taller? Since the woman standard deviation is higher, relatively taller, it would be part C, or sorry, the 5 foot 11 inch woman. Okay, problem question number 3, same idea. So we want to look at this particular problem. So we have two students. The art history test, the person scored a 73.5. And Molly took a math test and earned a 68. So I'm going to do some highlighting here. So we have art history in yellow. And then if you continue reading, the mean of the art history test, I'm going to highlight in yellow, and standard deviation are in yellow. And for the math test, I'm going to highlight that in green. So we want to calculate the z-score for each particular test. So for Chastity, we're going to use the yellow. So for Chastity, the z-score is going to be her score, 73.5, minus the mean, 76.9, and we're going to divide by the standard deviation of 10.2. When you do that, you get negative 0.33. So that's for part A. For part B, we're going to use what I've highlighted in green because Molly took the math test. So for Molly, her test score was 68. So 68 minus the 62.9, and we're going to divide by the 8.2. Doing that on the calculator, I get 0.62. So she's 0.62 standard deviations above the mean for the math test, and Chastity is negative 0.33 standard deviations below the mean for the art history test. So relative to their peer group or the test, who did better, that would be Molly, because her standard deviation is higher. So hopefully that helps you understand z-scores.